problem number 207, course schedule. There are a total of 9 courses you have to take, labeled from 0 to 9 courses minus 1. You are given an array prerequisites, where prerequisites I equals AI and BI indicates that you must take course BI first if you want to take course A. For example, the pair 0, 1 indicates that to take course 0, you have to take course 1. Return true if you can finish all courses, otherwise return false. Okay, so for example, I think if like so false. Oh yeah, if we have 1, then it must be false. And maybe like like example 2, it like having course 1 you have to take 0 first, and having course 0 you have to take 1 first. So it is impossible. It is a cycle. Okay, so for this we will have to check if this prerequisites forms a cycle. If not, then we can return true. If yes, then we will return false. Okay, so we will traverse the graph. We will first build the graph and then traverse it. And if we found cycle that because so we can define it is a directed graph because if you take you must take course B before take A, so it's like B to A. I can define like this, B to A. And so we can build a graph first. Build graph. We're using a dictionary, and key will be the course, and value will be a list that contains this key will be the prerequisite, the course that you have to take first, and value will be courses that you can take after having the key. Okay, and then we will traverse use DFS to traverse the graph and I'm thinking of we will use DFS to traverse the graph, and if we find cycle, cycle will be that is found a visited node that is not your parent. Yeah, like if we find cycle, then return false. If we are safe, then we will return true at the end. Okay, so so time complexity will be if we build graph, we will loop through the prerequisites array, and it will be the p length plus n courses plus the connections of courses, but it will be p as well. It will be edges. There are p edges, so it's p. So p is the length of prerequisites. So build a graph. We will have a pre-graph that will be default ticked and default to an empty list. So we'll for loop we will so A and B in prerequisites. So pre-graph key will be the course you have to take first. Okay, so B and append A. Okay, it's a directed graph, so we don't need a reverse version. Okay, so after building a graph, we will traverse the graph. And we will have a DFS. And we will have a for loop to check. We should traverse the graph. So after one connected component is found, there might be others are missed. So we have to traverse all the nodes, all the courses. Okay, so for nouns courses, yeah, for course that says C in range noun courses, yeah, we need a visited set. So visited wait, I think maybe we should reset the graph every time each node starts, because like it is a directed graph, so started from every node, like if some node is already in the visited set, it doesn't mean it will create a same root with the root before. So I think we should reset the visited set every time. So it's like, okay, we will have like this, and GFS C, and and if nothing went wrong, we will okay. Okay, we should first add I into the visited set. So visited add I, and for its connections, for course in, okay, I think we should use like, for nodes in graph, in pre-graph I, if you find a node, if node is, we need like, where did you come from? If node let me think, like if node is already in the visited set, no, like if like node is already in the visited set, and you need your previous, like where it's your parent. So if node not, let's first finish this. If node not in visited, then we will have DFS node, and you come from I. Yes, so it's parent, and else if node in visited. Okay. Else if node not like this, no, it's not equal to parent, then we found, we will return we'll find a cycle, return true. Otherwise, I think we should do it like we will have cycle and say cycle equals false, and we will have cycle equal to true, and return, we'll return now. Parent and this parent should be I think it's no. Like none. But okay, so time complexity, because we reset the visited set every time, so this will be n, multiplied by n. Okay, maybe let's try run first. We will first see that one has a cycle, so we will have this dictionary as 0. We'll have 1, and 1 will have 0, and Okay, so let's start our DFS. Okay, so for range non-courses, it's 2. So we'll start from 0. C is 0. DFS 0 was none. Oh, we need non-local cycle. Okay, so now C is 0, none. So visited add. Okay, let's have visited set here. We'll add 0. And for node in trigger graph 0, we'll have 1. Node is 1. 1 is not in the visited set. Okay, so we will run the DFS, and node will be 1, parent will be 0. So we will add 1 into the visitor set, and then for 1 we have 0, so node is 0. So now 0 is in the visitor set. Okay, and 0 does it equal to parent? Parent is parent is 0. I think if you visit I think only found a visitor node, and it's a cycle already. So maybe we will have then we will return okay, and cycle is true, so we'll return false. Okay, let's see the example 1. So for this, it will be only like this. And course will be 2. We'll start from 0 as well. So it's DFS 0 not. Okay, so we don't need parent. So 0, DFS 0, we will add it to the visited set. 0 will have node 1. 1 is not in the visited set, so we will have DFS 1. We will add the 1 into the visited set, and 1 does not have, so we will finish the for loop, return, and cycle is false. Okay, and then we will have 1 in the course. One for 1, and then I will reset the visited set, and DFS 1. Okay, DFS 1, we have visited added 1, but we don't have for loop, so we will return, and cycle is still false, so we will return true. Okay, let's check. Oh, what's wrong with this? So its graph will be 4 will have 1, and then 4 will have 2, 1 will have 3, and 2 will have 3. It's like, okay, so for having 1 and 2, you should for having 1, you'll have so having 1 you can have 3, and then having 2 you can have 3 as well. Oh, then that's not a, it's a cycle, but you it's a cycle, but you can finish that. Okay, so I think it's the cycle. It's this thing, we have some misunderstanding, we have some mistakes here. So, like, what should we find? Or is now we should find but like for example, this is not like it will have 4, 1, 3, 4 can have also like I'll have it here like 4, 1, 3, and 4 can also have 2, and it can also have 3. And it has no problem. But then if you see, if you have 1, if you have like 4, 1, 3, but then 3 needs 4. Oh, like, when you visit somebody in the visit set, but this will not. Like, 4, you visit, you start with 4, Or is it because we start with others? We start with start with 0 and 0 does not, so we will return. We start with 1. 1 will have 3. 3 will be in the visited set. No, 1 will DFS 1, so 1 will be in the visited set, and then 3 is not visited. We'll have DFS 3, so we will have added, and then 3 has nothing connected, so we will return, and 1 has nothing to for loop, so we'll return. So cycle is still false. Then we will start with 2, DFS 2. So for DFS 2, we will have visited set added, and it has 3 in the graph. Okay, so we will have, we will visit DFS 3, and we'll add it to the visited set, and 3 does not have any connected nodes, so we will return, and 2 does not have any more, so we will return as well. Cycle is still false, and so let's tab, first, now we have C equals 3, but 3 does not have any connected nodes, so now we'll add 3, but then nothing, so we'll return, and it's still false, and then we will start 4. Okay, so for 4, added to the visited set, we have 1 and 2. So for 1, I think, so for 1, it is not in the visited set. We will add, we will have DFS 1, we will add it to the visited set. For 1, we'll have 3. 3 is not in the visited set, so we'll add it. Then okay, so 3 does not have anything to for loop, we'll return. I think this visited set is a bit tricky, if you find a path, then you should if I do it like this, added, and then when you return, you should pop visited, remove, then time complexity will be very large, but I think this will work, and we don't need to reset. This will work, I think. Oh. But the time complexity will be large. It will be 2 with the power of and plus P. Yeah, like the possible path. Yeah. So we cannot do it like we cannot do it like this. I think we should add some like parameter like parents or so, or and that still remain sharing the visitors that don't remove. But yeah, we should add something like how can we differentiate this is like the node is not in the node is in the visitor set is because it is its parents, or it's just like the same level thing, like, or we should memorize its parents, like like we should maybe use like 3 cannot be connected to 1 and 4 and 3 itself. But yeah, if we change to another path, it can be correct. So how can we implement this? Like, I want to check the solution. Okay, it is like its visitor set has status. So yeah, it will indicate its let's see. Okay, so it's videos that has status, so it creates like like when it is 0, it means the node is not visited. So we will have nums courses and so 3 status for visitors array. 0 will be haven't visited yet. 1 will be current visiting. And 2 will be finish visiting. So it's like, okay, so when you are at 4, your connected node has 1 and 2. So for 4, you will have like, you will have 0 first, like default, all defaults to 0. And when you have, like here we will add it to like visited I will be equal to 1. It's current visiting. And for node, I think like after the for loop, that means you have finished all the connected nodes you have, so you will have equals to okay, then let's redefine if node not in visited will be if node is 0, if visited node is 0, then we can visit. If visited node is 1, that means you have reached the parent. So cycle will be true. We will return. If visited node is 2, then it's basically it's already visited, so we will not visit again, and it is not like this. I think it's like the 2 visit 3 3 already finishes visiting, so we will not visit again, but you did not. It is not a cycle. Yeah. So and for this okay, I'm not sure if we need to reset the thing. Yeah, I'm thinking of edge cases, like like this one, and then maybe I'm adding like 2, 5. Oh no, like 5, 2, and I think we should reset. Yeah, like okay, the solutions I don't need, but why? Oh, I think you don't need to reset because the node that you have already visited it is gonna be if you have already, like, if you finish DFS without cycle, then that means every node of the one that you have visited is you already finished it, and there will not be connected nodes outside to other nodes, so it will not form other cycle between these visited nodes. So you don't need you don't need to reset, and Yeah, I will say if visited C equals 0, then oh. I deleted cycle. Cycle is false. Okay, so this will not be n, it will be n plus p.